We have four isotopes of lead are shown below, each with its percent mass abundance, and the composition is drawn here for you of its nucleus is where most of the mass is. Oh, I wonder what this is. Okay. All right, calculate the approximate. That's nice. Approximate atomic mass. Let's get the weighted average here. Protons and neutrons are going to have a approximate atomic mass unit of 1 each. And to get the weighted average, we're simply going to use this formula. All right, so let's just do this part here in this color here, maroon. It's going to be the mass of that isotope times its percent abundance, and we're going to add that to the mass, do this one in that color there, red, of the second isotope times its percent abundance. We're going to add that to the mass of the third isotope times its percent abundance, and add that to the right there, mass times its percent abundance, and you would just keep doing this until you ran out of space. Just kidding. You would do this until you ran out of isotopes. All right, let's do it. The mass of this first isotope is going to be 82 plus 122. That's going to be 210. No, 204. All right. Sorry about that. AMU. I'm going to run out of space if I write this big, but all right, let's move that decimal over twice to the left. 0.014. Got rid of that percent, turned that into a decimal. Let's add that to the mass there is 207 units times 0.22. I'm getting a little sloppy here. That's the relative abundance. Move that decimal over twice. Okay. Let's add that to this here. 82 plus 124. That's a 6, and that's 206 units. Relative abundance, move that decimal over twice, get rid of that percent sign, 0.241. Let's add that to our final isotope here is going to have a mass of, there's an 8, 208 units. Okay. Move that decimal over twice, 0.524. All right, 204 times 0.014. 2 sig figs because there's going to be 2.9. All right, because that number has 2 digits, 2 sig figs. So it's 2.9 units is the component of the first isotope. That makes sense. It's only it makes up 1%, about 1%. Second one here is in red is 207 times, my calculator is covering up, but I can see it's on the left side is 0.221 is the percent. All right, and so that's going to be 3 sig figs, 3 sig figs. I need 3 sig figs, so it's 45.7 is that part there, plus 45.7. Right, because that has 3 and that has 3. My answer after I multiply has to have 3 significant figures. And let's add that to this green. 206 is the mass times 0.241. All right, so 3 sig figs times 3 significant figures is 49.6. 49.6 atomic mass units is that component. That kind of makes sense, you know, like they make up roughly about the same. All right, now this last number should be the biggest number because it makes up more than half of all the isotopes of lead. The mass of that is 208 times, my calculator is covering up, but again I can see it from on the left side of the screen is 0.524. That's again 3 sig figs times 3 sig figs. It's going to be 109. Okay, so our answer can't have any decimals because of this one. Doesn't have any decimals. So our answer has to have precision to the ones place. Let's add them up. I'm not going to do that in my head. I'm just going to use my calculator. The whole number answer is 207. Our final answer is, what did I just say? 207 atomic mass units with proper significant figures.